Between 1973 and 1993, the estimated concentration of aquatic mercury reported in national databases decreased 100-fold. Today, scientists believe this decrease reflects the use of more reliable sample collection and analysis techniques. In fact, recent advances in clean sample handling techniques and analytical methods indicate that metals concentrations historically reported in databases may be due largely to sample contamination rather than to actual sample concentrations. As EPA and states increase their reliance on water quality-based permitting under the Clean Water Act, it becomes more and more critical to reliably and accurately measure pollutant concentrations in our nation's waters. The most serious problem associated with making reliable measurements of trace metals at water quality criteria levels is precluding contamination during sample collection and handling. Avoiding contamination requires being aware of the numerous routes by which samples may become contaminated. Some of these sources include atmospheric inputs such as dirt and dust, improperly stored or dirty equipment, and exposure to metal structures such as bridges, wires, and poles, or metal-containing equipment. Human contact can be a source of contamination from metals clinging to skin or clothing surfaces. To ensure that metals data accurately reflect metal concentrations found in the water body sampled, the United States Environmental Protection Agency's Office of Water has released draft guidance for collecting trace metal samples from ambient waters and is in the process of developing similar guidance for collecting effluent samples. The sampling techniques presented in this video are based on this guidance and represent a clean sampling philosophy that can be applied to many sampling scenarios. In recognition of the variety of situations to which clean sampling techniques may be applied, and in recognition of continuing technological advances, the methods are performance-based, allowing for alternative procedures, so long as those procedures are demonstrated to yield equivalent or superior results. The following presentation illustrates the clean sampling techniques outlined in EPA's guidance as implemented for ambient sampling and adapted for effluent sampling. Accurate analysis of trace metal concentration in wastewater treatment effluents can be a vital tool for determining regulatory compliance as well as treatment process efficiency. Good planning and awareness of potential contamination sources can result in the development of convenient clean sampling techniques that can be routinely applied to save both time and money in the long run. The sampling equipment must be thoroughly cleaned and protected from contamination before it is brought to the sampling location. Though cleaning techniques may vary depending on the metal of interest, general procedures involve the use of acid baths and reagent water. It is important to verify that the facility used to clean the collection equipment and bottles has appropriate quality control procedures in place and has generated equipment blanks demonstrating the equipment is sent to the sampling site free of contamination. Materials known to contain metals should not be used to collect samples for trace metals analyses, or at the very least, should not come into direct contact with the sample water. EPA guidance lists materials that are recommended for specific metals of interest. Storing equipment in clean double bags during transport and until use provides a simple means of ensuring that the equipment remains clean until sample collection. The collection and analysis of field blanks are necessary for determining and tracking contamination that may occur during sampling procedures. Field blanks can be collected from metal-free reagent water that has been tested before being brought to the field. The blank water should be processed through the sampling equipment and into sample bottles with the same techniques used to collect the actual samples. In this way, contamination can be detected and monitored. The use of a peristaltic pump for sample collection is an excellent way to avoid sample exposure to contamination sources. The peristaltic pump does not come into direct contact with the sample water. Clean, metal-free, flexible tubing fitted into the pump head will supply blank reagent water and sample water to collection bottles while preventing contact between samples and the pump or other sources of contamination. Samples that will be analyzed for dissolved metals can be filtered during collection using a pre-cleaned 0.45 micron capsule filter connected in line to the sample collection tubing. Samples are pumped through the filter directly into sample collection bottles, eliminating potential contamination that can result from additional handling. A simple metal-free pipe can be used to hold sampling tubing firmly and provide a convenient way to access representative sample water while avoiding sample contact with any source of contamination. The inlet end of the tubing can be oriented easily to collect sample water from a specific location. These collection bottle caps can be used in conjunction with sample containers and are consistent with the clean techniques and performance-based approach emphasized in EPA's sampling guidance. The caps allow very little contact between the sample and contamination sources. The design is just one innovative idea that can be applied to sample collection with clean sampling techniques in mind. It is important to practice clean sampling techniques even in the planning stages of a collection effort. Excess equipment, disorganization, or shortcutting can result in contaminated samples even before sampling activities have begun. Once on site, sampling personnel cover themselves and the equipment as much as is practical and necessary to prevent sample contamination via metals adsorbed to skin, clothing, or equipment surfaces. Wearing more than one pair of gloves allows for easy removal should the outer pair become contaminated. The level of protective gear necessary varies according to site and to target analytes and concentrations. Contamination can be reduced significantly by using a two-person sampling approach known as clean hands, dirty hands. Both team members wear protective clothing, but all operations involving direct contact with the sample and sample bottle are handled by the person designated as clean hands, and all activities that do not involve direct contact with the sample and sample bottle are handled by the person designated as dirty hands. Though the clean hands, dirty hands sampling technique requires some coordination, its importance lies in its application of the clean sampling philosophy. As with all sample collection efforts, it is recommended that field blanks be taken with every sampling event. Blank reagent water should be collected into sample bottles through the sample collection tubing using clean sampling techniques identical to those used for the collection of actual samples. The importance of field and equipment blanks as a tool for evaluating sources of contamination cannot be overemphasized. In this demonstration, Dirty Hands has opened the storage cooler, removed the clean, double-bagged sample bottle, and unzipped the outer bag. Clean Hands reaches into the outer bag, opens the inner bag, removes the bottle, and collects the sample. Field blanks and samples are collected by the Clean Hands, Dirty Hands sampling team, with the Clean Hands team member handling sample bottles and the filter apparatus, and the Dirty Hands team member handling pump operations. After sample collection, the samples must be preserved either in the field or a clean laboratory facility according to specific analytical method requirements. Before transport to the laboratory, all samples are double-bagged and placed in a cooler as quickly as possible. Record keeping is a required aspect of field activities. Sampling location, time, and conditions are recorded along with any known chemical or physical parameters or unusual observations. Because many permits require the collection of composite samples, and because the use of automated compositing devices can be less labor-intensive than collection of multiple grab samples, automated compositing devices are also being evaluated for sample collection. The automated compositor shown here is only one example of an automated device that can be developed for efficient sampling. It is constructed as a closed system, applying the same clean concepts just presented by the Clean Hands, Dirty Hands sampling team. Use of a peristaltic pump and clean metal-free tubing ensures the sample water collected is not exposed to contamination sources. Until the feasibility and efficiency of inline filtration has been fully evaluated for composite sampling, composites collected for determination of dissolved metals have been filtered after the entire sample has been collected. Water collected with the automatic sampler can be processed under clean and controlled conditions in a laboratory or clean area on site. Clean sampling techniques are not meant to imply an expensive, burdensome, or impractical sampling scenario. If we instead manage an awareness similar to that just demonstrated of potential contamination sources, clean sampling techniques can be developed and applied easily in a way that is both convenient and site-specific, depending on the suspected levels of contamination. Clean sampling techniques have been of great benefit in determining that either an environmental problem does not exist or that the magnitude of the problem is considerably less than initially envisioned. For this reason, the added costs associated with clean sample collection and handling are often trivial when compared to the cost saved by avoiding unnecessary pollution controls that might otherwise be required. The collection of samples for accurate determination of trace metal concentrations in ambient water is an important tool for characterizing the environmental conditions of rivers, streams, harbors, and other water bodies, and for evaluating the impact of effluent discharges on receiving waters. As with the clean sampling techniques that were just demonstrated for the collection of effluent samples, all ambient sampling activities begin with clean and prepared equipment. Because most ambient sites are not as accessible for sample collection as wastewater effluents, ambient sample collection requires extra attention to sampling efficiency. Here, portable equipment will be used, including a battery-operated peristaltic pump and filter apparatus, gloves, sample collection bottles, a metal-free pipe or sampling wand to enable sampling activities in midstream, and a weighted collection bottle to enable sampling from a bridge or high structure. The sampling team should disturb the stream bed as little as possible and approach the sampling site from downstream. This will minimize sample contamination and ensure samples are most representative of actual stream water conditions. Before wading toward the sampling site, the team should be fully prepared with equipment that is easily carried and readily available. The sampling crew may want to wear several pairs of gloves and carry a waste receptacle for easy disposal of contaminated items, such as used gloves or used filters. The more efficient the sampling apparatus and procedure, the less chance there will be for sample contamination. The sampling wand again provides a convenient way to collect representative samples. The notch in the wand holds collection tubing above the stream bed, upstream from sampling activities and away from the collection team. While samples for total metals can be collected simply by placing a clean sample bottle directly into the stream, samples for dissolved metals can be collected using the same principles of inline filtration used with the collection of effluent grab samples. Samples for dissolved metals can also be filtered after collection in a controlled environment in a manner similar to that demonstrated for effluent composite processing. Occasionally, a boat may provide the easiest access to a sample location. In such cases, attention should be paid to the condition of the boat. The sampling team should be aware of any potential sources of contamination, such as rust, fuel exhaust, or discharges. Ideally, the boat is positioned downstream and downwind from the sample collection point. Covering the area of the boat where sampling activities will occur helps avoid sample contamination from boat surfaces. Once again, samples are collected using clean equipment and clean hands, dirty hands techniques with as little exposure to potential contamination sources as possible. With careful planning and organization, boat collection of trace metal samples can be a safe and contamination-free means of obtaining water quality data. If necessary, a bottle can be designed to collect samples from a bridge or other location where a body of water may not be easily accessible. This bottle shows tubing fitted into the bottle body to reduce sample exposure to atmospheric contamination. Plastic-coated concrete weights orient the bottle upside down below the water surface. The sampling methods presented have been found suitable for the collection and filtration of water samples for the determination of total and dissolved metals at water quality criteria levels. Less stringent procedures may be suitable when monitoring at higher concentration levels or in less contaminated environments. The particular methods shown are intended to serve not as specific procedures to be used, but rather to present the elements of clean sampling techniques. A quick review of the clean sampling concepts just presented will highlight specific approaches that can help ensure collection of contamination-free samples. To ensure clean conditions from the very beginning, planning and organization are important. Excess equipment, disorganization, or shortcutting can result in contaminated samples even before sampling activities have begun. Materials known to contain metals should not come into direct contact with sample water. Equipment should be clean and free of contamination. Sampling personnel should cover themselves and the equipment as much as is practical to prevent sample contamination via metals adsorbed to skin, clothing, or equipment surfaces. Contamination can be reduced significantly by using a two-person approach known as clean hands, dirty hands. Samples for dissolved metals can be collected through a clean inline capsule filter, eliminating contamination that can result from additional sample handling. The procedures you have just seen have been found to be suitable for procuring samples free from trace metal contamination and are recommended for the collection of ambient and effluent samples. Remember, this sampling guidance is performance-based. The United States Environmental Protection Agency recognizes that a number of procedure modifications may prove either necessary or more practical and encourages their use, provided they result in the collection of samples and blanks that are free from contamination at the levels of interest. It is highly recommended that any modification be thoroughly evaluated and demonstrated to be effective before field samples are collected. As EPA and states increase their reliance on water quality-based permitting under the Clean Water Act, it becomes more and more critical to reliably and accurately measure pollutant concentrations in our nation's waters.